Okay, next for example number 14. Okay, the question says that a whistle from a stationary policeman emits a sound of frequency 1000 Hz. So automatically from this question we know the policeman is actually the source. Okay, the policeman is the source, emits a frequency of 1000 Hz. So this one is the frequency of the source. Okay, if the speed of sound is 330 meter per second, so we have another new information here, which is our V. Okay, this is our V. What is the frequency of the sound heard by the passenger inside a car which is moving with a speed of 20 meter per second? Okay, frequency heard by the passenger inside the car. So the passenger inside the car is actually our observer. Okay, the passenger inside the car is our observer, and this is the speed of the observer. Okay, so they want us to calculate the frequency of the sound. Okay, they want us to calculate the F0 or F0, FO when the observer is moving towards the junction. So we have a policeman here who is actually blowing the whistle. Okay, and then we have a car. Okay, a passenger and observer inside a car which is moving towards the policeman. Okay, so as the observer move towards the policeman, we know the frequency of the observer will be larger than the frequency of the source. Okay, the frequency of the observer will be larger than the frequency of the source because they are moving towards, the observer is moving towards the source. Okay, so when we write down our equation, we will have F0 equals to Fs, then we always have V over V. Okay, so right now the policeman is not moving. So when the policeman is not moving, the velocity of the source is equals to 0. Okay, so when the velocity of the source equals to 0, we cannot disturb the denominator. Kita boleh kacau belah atas sahaja. Okay, so velocity of the source is 0. So when the velocity of the source is 0, the velocity of the observer is the one which is moving. So we have the velocity of the observer here. So now we know the frequency of the observer should be larger. Okay, so again, for us to get a large number here, the value here should be big as well. Okay, if the value here is larger, then we can get a larger value here. So we can add this up. Okay, so this is going to be the equation for us to use. So F0 equals to V, which is 330 plus V of the observer, okay, speed of the observer, which is 20 meters per second, divided by another speed, which is 330, multiplied by the frequency of the source. Frequency of the source, which is 1000 Hz. So frequency of the observer is going to equal to 1060.60 Hz. So again, we double check our answer. We know the frequency should have increases. So from 1000, and the frequency of the observer Hz is 1060.60 Hz. Okay, so this one is for the first case, when the observer is moving towards the source. Okay, so for the next one, the observer is moving away from the junction. That means we have the policeman here who is still blowing the whistle. Okay, and the observer in the car who is moving away. Okay, the observer in the car who is moving away. So as the observer move away, the frequency heard by the observer will decrease. So it will be smaller than the frequency of the source. Okay, as the observer tu makin jauh dengan kita, okay, the frequency of the observer, frequency yang observer itu dengar lebih kecil, makin kecil. Okay, so frequency of the observer reduces, frequency of the source is going to be larger. So when we write our equation, we will have F0, so still we will have Fs here, we will have V over V. Okay, but this time we will still have V observer here. Okay, but this time we want a value which is smaller here. So for us to get a value smaller here, the value here should be small as well. So the value here should be minus. Okay, so this is our equation. So we can just substitute the value, which is 340 minus 20, 330 minus 20 divided by 330 multiply by the frequency of the source, which is 1000 Hertz. So when you press your calculator, you will get frequency of the observer is actually equals to 939.39 Hertz. So this is the frequency heard by the observer. So that is for example 14.